morning, students. Today we start new chapter, chapter number 4, motion in a plane. In first topic 4.2, scalars and vectors. In chapter number 3, we already discussed only for the one dimension. Only for one dimension. Here we discuss motion in a plane means 2D in 2 dimensions. So first here in scalar quantities, here we all know that scalar quantities is only depend on magnitude. Only scalar quantities only depend on magnitude. Okay. Other and second one is vectors means vector depend on magnitude plus direction. Magnitude plus direction. Now here we know that speed is scalar quantities, vector quantities. Speed is scalar quantities. Just because of speed depend on only value magnitude. Speed always positive value. Distance always positive, not negative. Okay. Now in second vector is depend also on direction, means second is displacement. We already discussed. In displacement case, displacement depend on magnitude and direction. Okay. Now next, position and displacement vectors. Now here in this case, here we consider x and y plane. At any object moving initially position at P, position vector of this object is R. This object moving to this path and shift another one point P dash. In this situation, position vector of this situation is R dash. Okay, in this situation. So position object move from P to P dash. Okay, P to P dash. But here we already know displacement is only on depend on final position and initial position, not which kind of path, not which kind of path. Only displacement depend on final minus initial position. Okay. So here displacement from P to P dash directly in this case, not this curve path. Now next is equality of vectors. Here equality of vectors means suppose we have two vectors, vector A and B, two different type of vectors. So here in this case vector A and B means equality. A is equal to B. How? In this case magnitude of this vector means total length of this vector is same, means value magnitude of this A vector and B vector means equal. First one condition. Second one is vector A and B direction is same. Direction of this vector A and B is same. So in this case A is equal to B. Now another one, take example A and B. Here in this case magnitude of vector A is equal to B, but direction of vector is different. Direction of these two vector is different. Okay. Now next point, multiplication of vector by a real number. Multiplication of vector by a real numbers. next point is 4.3, multiplication of vector by a real number. Suppose we have one vector A. This A vector is multiplied by a real number lambda, positive real number lambda. So is equal to, in this case, this one. Okay, lambda is 8 greater than 0. Okay, more than value जो है lambda is more to 0. So in this case, lambda is real number. Here lambda is positive value. So lambda into A. So in the first case, vector A, this vector A multiplied by 2. This vector multiplied by 2 means is equal to 2A. So in this case, 2A almost double. 2A means here in this case, direction of vector is same. Magnitude of this vector is as compared to double to this one. Okay. Now second one example here we take. In second one example, this one positive and negative. So magnitude of vector A and minus A same, but direction of this vector is opposite to the direction. Again same for the multiply by 1.5 minus 1.5. So magnitude of vector is minus 1.5 A. Okay, minus 1.5 A. Now addition and subtraction of vectors. Topic is 4.4. Now suppose we have two vectors A and B. Okay, how to addition? In first case, we have from origin vector A O to P. Now second vector is addition with this case. So in this case, tail of B connected with head of A. Tail of B connected with A. Now, so resultant of this vector, addition of this vector is this. So resultant R is equal to A plus B. R is equal to A plus B. Addition of two vector A and B is resultant R is equal to A plus B. Okay, this is the addition of vector. Now again here we take two vectors A and B. Now same for the vector 3. So in this case, A, second vector is A. Second one here we take example in this case. So vector in the position B, this vector A, and resultant of this one. So is equal to R is equal to B plus A. R is equal to B plus A means A plus B is equal to B plus A. Okay, in this case, now here we take vectors, vector A, vector B and vector C. So in this case, resultant of vector A and B, this one, resultant of vector A and B. So A plus B. Now second one, resultant of B plus C, means this one. So B plus C, resultant of vector B plus C, and resultant of vector A, B and C is equal to this one, means start from A, B and C. So this one is resultant of A plus B plus C. So here A plus B plus C, otherwise A plus B plus C. Okay. So this is the addition and subtraction of vectors. Now subtraction of vector. So in this case, subtraction of vector, here we have vector A, vector B and vector minus B, opposite to the direction. Okay, vector A, vector B, opposite to the direction but same magnitude. Okay, magnitude is same but direction of vector B opposite to the direction. So in first case, addition of subtraction of in this vector A and B R is equal to, here we know that A minus B, resultant of A minus A and minus B, vector A and vector minus B. Now in same case, resultant of vector A and vector B is this one. So A plus B. This is the subtraction of, in this case, vector. Now next one is, suppose two vectors A and B origin is same. Origin of these two vectors in this case same. So how to find a resultant of vector R? So in this case origin is same. So here we know that vector A parallelly one dotted line represent this one. Parallel means same magnitude and direction. Okay, same magnitude and direction. Again same for second one. So here we get resultant of in this vector. Resultant of this vector. This one is A, this one is B. So resultant of this vector, one type of a triangle addition. Okay, this will be A. So this is the parallelogram theorem. In this case, parallelogram method of vector addition is equivalent to the triangle method. Equivalent to the triangle method.